Hi folks, Will from MinIO here, and in this video we're going to be talking about recovery after failure if you have a drive or a node go down in your MinIO deployment. Now, both of these recoveries are highly dependent on having erasure code set up. So if you need to do a quick review of our erasure code videos, you can find the link to those in the description below. But for this video, we're going to talk mostly about what happens when a drive or a node fails. In the next video, we're going to do a little demonstration of that node failure. And in the final video for the series, we're going to talk about site recovery. But let's go ahead and dive right into disk and node recovery. Since disk and node recovery are both highly reliant on erasure code, I'm going to do a brief review of erasure coding. For those of you who've viewed our erasure coding videos, you can skip ahead a little bit. But for those of you who have not, here's a quick review. MinIO Erasure Coding is a data redundancy and availability feature. It's designed to recover objects in case of loss of a drive or even a node. The number of nodes or drives you can lose is a function of your parity setting in your erasure coding. We're going to see an example of that in our demonstration video coming up next. But each new object, when it is written to MinIO, is broken up into data and parity blocks. And the object can be reconstructed with a certain number of those data and parity blocks, no matter which data or parity blocks are still remaining in your system. This makes your system highly resilient against the loss of drives or even the loss of a node. Now, if we're talking about a drive recovery, the nice thing about MinIO is that drive recovery is available with hot swapping. If you have a drive go down, you don't even need to restart MinIO. Provided your operating system can handle hot swapping of drives, MinIO can work with that. MinIO will detect when a failed drive is replaced. So you don't have to restart MinIO, you don't have to restart the node, you don't even have to restart the cluster. The healing will happen automatically for you. You just need to make sure that you take certain steps. Here they are for you. First of all, obviously, you want to unmount that failed drive. You got to get it out of there. You can't just recover that drive by itself. Once you've replaced the failed drive, you're going to want to go in on Linux and review your FS tab. Remember, MinIO expects drives to be named sequentially. Okay, so you want to make sure that you're replacing this drive with a new mount point that is the same sequential number that the failed drive was. Okay, once you've done that in your FS tab, you're going to remount the replaced drive. And then just monitor your MinIO logs or take a look at mcadmin heal to see the progress of healing of your drive. Again, you don't have to restart MinIO. Provided your operating system can hot swap drives, you are good to go. Take a look at our documentation here. This documentation gives you a lot more detail on all the little sub-steps you might have to take, but this is really what you need to do if you need to replace a drive. At the next level up, if I have a cluster of MinIO instances running in my deployment, I might need to recover from a node failure. This is when an entire server goes offline for whatever reason. Could be a power supply failure, could be the operating system has just crashed on you, whatever it might be. So replacing a node is actually similar to replacing a drive. You don't have to restart your cluster. MinIO is going to look for the lost node in the background. We'll see this in the demonstration I'm going to do. And when this node is replaced, it's going to begin healing immediately when it rejoins the cluster. Now, the important thing here is your erasure code parity setting. Your erasure code parity setting must be sufficient to cover the loss of all the drives in a node. In our example, we're going to have 4 nodes with 2 drives each, so your parity setting has to be at least EC2. This is so that 2 drives can be lost and your cluster remains functional. If your parity setting is set too low or reduced redundancy is used, data loss is possible. So you want to make sure you've set your parity high enough so that you can lose an entire node without losing data. So let's take a look at the steps for node recovery. Again, you're going to start up your replacement node. Make sure that the host name for the replacement node matches the host name from before. Again, the node names are sequential in MinIO. So you want to make sure that you have the same node name, host name set up when you come back in. Usually this is done if your IP address has to change. Obviously, if you can just assign the same IP address to the new node, chances are your DNS entries will just pick up the name with no problem. You're going to want to make sure that you then install MinIO with the matching server versions, and also make sure you replicate your service and environment configurations from the rest of your cluster. After you've done this, go ahead and start up that MinIO server process. When you start the MinIO server process, you want to use that same server command with all of the nodes and all of the drives that you used before. Again, we'll see that in our demonstration. And then you want to monitor your MinIO logs and mcadmin heal, just like you did for a drive recovery, to make sure that everything is coming back online. If you want to learn more about this, go ahead and take a look at the documentation there at the bottom of the screen. This covers all of the sub-steps, again, that you might need to go through to make sure that your node rejoins your cluster as seamlessly as possible. And that's it for our video around disk and node recovery. In our next video, we're going to do a little demonstration of node recovery. Thanks for watching, and if you enjoyed this video, you can reach out to us using any of the methods you see here on the screen. You can join us on Slack at slack.min.io, or just leave a comment here on the video. Thanks, and we'll see you for the demonstration.